Okay, we're getting ready to start Module 3, and this is page 44. Are you ready? So please join me on page 44. All right, so the first clue here, or the first skill here, is to write an improper fraction as a mixed number. And so what I'm going to do is I'm just going to start with a whiteboard here. Because I think what they're doing here might be just a little bit confusing for you at first. So we're going to start with the improper fraction. This right here is the improper fraction, 11/3. And definition of an improper fraction is when the numerator is greater than the denominator. And we're going to convert that to a mixed number. A mixed number is when you have a whole number with a fraction. And 11/3 is equal to 3 2/3. And there's a pretty good chance in elementary school that you got taught a certain way how to do this. I'm going to review that with you. First thing I'm going to do though is I'm actually going to show you what they're trying to show you here, which really should make perfect sense if you can just follow along. So we're going to go back up and we're going to start with 11/3. Now what is 11/3? Well, it's too many thirds is what it is, because 3/3 is a whole. So I'm going to write 3/3, and 11 is more than 3, so I need some more thirds. So I'm going to add another 3/3. Now I'm going to try to explain why this makes sense. If you have 3/3 and then you have another 3/3, that's 6/3, and remember I started with 11/3, so I'm going to keep going. That's not enough. If I add another 3/3, that's 9, and remember we're going up to 11, so now I can't add another 3/3 because if I did it would be up to 12/3, so I'm going to add just a fourth one, which is just 2/3. I'm going to try to explain why this makes sense. Make my whiteboard just a little bit bigger here so it kind of makes sense. Now I'm going to ask you to focus just on this 3/3 right here that I'm circling. 3/3 is how much? Well, that's just one whole. And this 3/3 right here is how much? That's one whole. And this 3/3 right here is how much? That's one whole. And my last one's not 3/3, it's just 2/3. So what do I have total? I have 1, 2, 3 wholes and 2/3. And remember what we said the answer was? 3 2/3. So I hope what I just explained there makes sense. That's what the example was. What you probably thought about, the way you were taught this in elementary school, probably, I'll try to use the same words I thought you would have been taught. What you may have been taught in elementary school is if you knew the improper fraction, what you do is you ask yourself, how many times does the denominator 3 go into 11? And if you know your 3's real well, you know it goes in almost 4 times, but not quite. It goes in 3 times. So since it goes in 3 whole times, that's a whole number. And then you do 3 times 3, and what would you get? You get 9. And then you have to figure out the difference between 9 and 11, which is 2. And that difference is your numerator. And your denominator remains 3. Okay, so if you think you know how to do these, it might be a good idea to hit pause and try them. And then check your answers. And if you need a little bit more help, that's fine too. All right, so we're going to go ahead and go through the answers for numbers 1 through 4. The directions read to write each improper fraction as a mixed number. And number 1 is 7/2. And if I were to show my work the same way that the example was at the top, I would say, well, 7/2 would be a bunch of 2/2. 7/2 would be 2 over 2 plus another 2/2 plus another 2/2. So if I had 2 plus 2 plus 2, that's 6. So I'm at right now 6/2. So I need another half because 6 plus 1 would be 7. So now I'm going to show you why this makes sense. I've got 2 plus 2 is 4 plus 2 is 6 plus 1 more is 7. So it's 7/2. Now what I need to do is ask myself, what are each of these equal to? 2/2 is equal to 1 whole. That kind of looks like 11 here. I shouldn't do that. I'm just going to use an arrow. This 2/2 is equal to 1 whole. This 2/2 is equal to 1 whole. So I've got 1 plus 1 plus 1. That's 3 plus another half. So the answer is 3 1/2. Sorry if that handwriting is a little bit too messy. I'll clean it up here. I'm going to rewrite that one too. Make sure it looks like 3 1/2. Okay, this next one right here I'm going to do probably just the quicker way, kind of the way I did in you might have learned it in elementary school. 12/5 is going to be the same as, well, 5 goes into 12 2 times, almost. No, I was going to say exactly, but not 2 times exactly. It goes in 2 times because 2 times 5 is 10. And then to get up to 12, we'd have a difference of 2. So it's going to be 2 and denominator remains 2 2/5. 11 sevenths. 7 goes into 11 one time with 4 remaining, so it's going to be 1 and 4 sevenths. And I'll probably do one more just for variety of instruction here. I'll probably do one more like the example showed you. 15 fourths would be 4 fourths plus another 4 fourths plus another 4 fourths. And 4 plus 4 is 8 plus 4 is 12. I need to add 3 more fourths to get up to 15. So if you add all your numerators, you'd be at 15. And so each of these 4 fourths is equal to a whole. That's 1. That's 1. That's 1. So I've got 1, 2, 3 wholes. And then 3 fourths. So it's 3 and 3 fourths. Okay. Let's go ahead and check out the bottom here. Okay, so the next skill is exactly the opposite. The next skill is we're given a mixed number and we're supposed to write it as an improper fraction. And you can this one's almost even easier to understand the example. So check this out. The example is there's 3 whole. I'm just going to talk about the wholes for a minute. There's 3 whole. 3 would be the same as 1 plus 1 plus 1, so that makes sense. And then notice, I think I'll change color here. Notice the 3 fourths, it's just found as 3 fourths. Now let's go check out these ones right here. Each of these ones is equal to 4 fourths. Now the reason why they're equal to 4 fourths is because our denominator is fourths. Remember our denominator being a 4? So now we just have 4 fourths plus 4 fourths plus 4 fourths. That's 4, 8, 12, plus 3 is 15. So the total is 15 fourths. There's an even quicker way. We'll just check it out here as we go. So go ahead and try 5 through 8 and then resume the video when you're ready to play your answer or to check your answers. Okay, number 5 is 2 1/2. And so our denominator is halves. So what I'm going to do here is I'm going to take 2, and 2 is equal to 1 plus 1 plus 1/2. And 1 whole is equal to 2 halves. So I'm just going to take that 1 and make it into 2 halves, and I'm going to take that 1 and make it into 2 halves. So I've got 2 halves plus 2 halves plus 1/2. And 2 plus 2 is 4, plus 1 is 5. So my numerator is 5. My denominator stays 2. The answer is 5 halves. Now, if you know a quicker way to do this, for example, I'll show you a different way in number 6. If you know a quicker way to do this, that is fine. You don't have to take a long time to do these. You don't even really have to show all your work if you can just do it mentally. So check out number 6, what I'm going to do here. Number 6 is 4 3/5. And some of you were taught that if you just take your whole number 4 and multiply it by your denominator 5, you get 20, and then add your numerator, you get 23. That's a really fast way to do this. 4 times 5 is 20, plus 3 is 23, 23. Your denominator stays fifths, and that is the right answer, 23 fifths. Now this is definitely faster, but the reason why this example exists and the reason why I go over it with you is to make sure that you understand why that is. Number 7, the fast way to do it is 3 times 9, that's 27, plus 4 is 31, 31 over 9. And number 8, 2 times 7 is 14, plus 5 is 19, 19 over 7. All right, so I'm going to clear my answers here. Hopefully you got all those. And let's do the final, the end of this page right here, comparing and ordering decimals. Kind of switching skills here. We kind of covered this in Module 1 with whole numbers. So if you don't look super carefully, they all kind of look, like they're the same length, and some of the digits kind of look the same. So let's check out number 9. You have 8.86, which is also 8 and 8600ths, and you're comparing that to 8 and 6500ths. So what I do is I just look at the beginning of the number. I look at the whole number 8 and 8, and those are equal to each other. So that is, I need to move on to the 10th place to see which one's greater. And since 8 is greater than 6, that's the greater value. It doesn't matter what happens after that. So I can say that 8 and 8600ths is greater than 8 and 6500ths. So let's move on. I'm going to get number 10 wrong on purpose. And then I'll fix my thinking, okay? If I looked at the length of this value right here, and say that's 3 digits, and I looked at the length of this one and say it's 2 digits, I could make the mistake that that 732 thousandths is greater, but that's not true. So I'm going to go ahead and take my red pen. I'm going to cross this off. That's wrong. I'm going to erase that, and I'm going to clarify my thinking here real quick. Okay. If it's important to you that they have the same length, what you can do is actually annex a 0 to the back of this. Now they are the same length. You're not supposed to go for length. You're supposed to go for value. And so what I'm going to do is go to my my highlighter. 7 and 7 are equal to each other. 5 is greater than 3. So it doesn't matter that it's longer or shorter. Since 5 is greater than 3, this is the greater value. Okay, and the last one, they kind of look the same, but notice this has a 0 snuck in there. So check this out. If I go to the ones place, 0 and 0 are tied. If I go to the tenths place, 2 is greater than 0. So again, the length of it is not the determining factor. The last one, we're supposed to order these from least to greatest. And this one should really be semi-easy. We've got something 98 hundredths, 27 hundredths, and 34 hundredths. 27 is clearly the least number. So 27 hundredths, then 34 hundredths, then 98 hundredths. Okay, we are done with this page. Good job.